Have you ever wondered how the sun, a giant ball of gas, can produce such intense heat and light enough to warm our planet millions of miles away? Now that's a burning question indeed. It's all thanks to a process known as nuclear fusion. This is the sun's secret, the very heart of its power. The sun, like all stars, is an enormous fusion reactor where the simplest and lightest element, hydrogen, is transformed into helium. This process happens at the sun's core, where the conditions are mind-bogglingly extreme. We're talking about temperatures of around 15 million degrees Celsius and pressure, 200 billion times greater than that at sea level on Earth. Under these intense conditions, hydrogen atoms move so fast that they collide and combine or fuse to form helium. Each fusion reaction releases an immense amount of energy in the form of light and heat. That's the glowing warmth and light we feel and see here on Earth, a byproduct of countless fusion reactions happening every second in the sun's core. But here's where it gets even more fascinating. Albert Einstein's famous equation, mc², tells us that energy and mass are interchangeable. During nuclear fusion in the sun, a tiny bit of the mass of the hydrogen atoms is converted directly into energy. That's a lot of bang for your atomic buck, considering the sun consumes about 600 million tons of hydrogen each second. This energy travels from the sun's core to its surface and then the 93 million mile journey to us. This radiant energy, this sunshine, is the result of the sun's nuclear fusion, a process that's been ongoing for about 4.5 billion years. And it's expected to keep shining for about 5 billion more. Amazing, isn't it? The immense power of the sun, all thanks to nuclear fusion. So if the sun can do it, why can't we replicate this process here on Earth? Stay tuned as we delve into the challenges and potential of nuclear fusion right here on our home planet. Scene script. Replicating the sun's nuclear fusion process on Earth is not as easy as it sounds. Imagine harnessing the power of the stars right here on our own planet. That's the promise of nuclear fusion, the process that fuels the sun, and it could potentially provide us with a nearly limitless supply of energy. But achieving this on Earth is an incredibly complex task, and it's one that scientists have been grappling with for decades. The reason why nuclear fusion is so challenging comes down to the conditions required for it to occur. In the sun, this process happens naturally, because of the extreme temperature and pressure at its core. We're talking about millions of degrees and pressure so immense that they're hard to even comprehend. Replicating these conditions on Earth is, to say the least, a daunting task. But let's say we manage to create these extreme conditions. That's just the beginning of our challenges. The next hurdle is containing the plasma, the hot electrically charged gas where fusion occurs. This plasma needs to be held in place long enough for fusion to happen, and that's a tall order. You see, the plasma wants to expand and cool down, which would stop the fusion process. To prevent this, we use magnetic fields to contain the plasma and keep it away from the walls of the reactor. But maintaining these magnetic fields is a complex balancing act that requires a lot of energy and precision. And then there's the challenge of maintaining the fusion reaction itself. Once initiated, the fusion process needs to be sustained for it to be a viable source of power. This means continuously feeding the reaction with fuel while simultaneously extracting the energy it produces. These hurdles make nuclear fusion a formidable challenge. It's like trying to hold a piece of the sun in a bottle, while also trying to draw power from it. But despite these challenges, the potential rewards are enormous. A successful fusion reactor could provide us with a virtually inexhaustible source of clean energy, with no greenhouse gas emissions and minimal radioactive waste. These challenges make nuclear fusion a tough nut to crack, but the rewards could be game-changing. So, with all these challenges, you might ask, why do we even bother with nuclear fusion? An excellent question indeed. The answer lies in the incredible potential that nuclear fusion holds. The fuel for fusion, hydrogen, is abundant in nature. It's virtually everywhere, from the vast expanses of the cosmos to the water in our oceans. This means we won't run out of it anytime soon. Imagine an energy source so plentiful, we could power our civilization for billions of years. That's the kind of abundance we're talking about when we speak of hydrogen. Then there's the cleanliness factor. Unlike its cousin, nuclear fission, which leaves behind a trail of radioactive waste, nuclear fusion is remarkably clean. The process of fusion converts hydrogen into helium, a harmless byproduct that won't pollute our environment or pose a threat to our health. In an age where we're grappling with climate change and environmental degradation, The allure of a clean, non-polluting energy source is hard to resist. But perhaps the most compelling reason to pursue nuclear fusion is its potential to provide virtually unlimited energy. The amount of energy produced by the fusion of just a few grams of hydrogen is staggering. It's akin to the energy released by burning tons of coal or oil, but without the associated pollution or greenhouse gas emissions. And remember, this isn't just theoretical. The sun, a natural fusion reactor, has been powering life on Earth for billions of years. If we can harness this process, we could potentially solve our energy problems and set humanity on a path towards a sustainable future. But, of course, it's not all sunshine and rainbows. There are formidable challenges to overcome. The temperatures and pressures required to initiate fusion are extreme. The technology to contain and control these conditions is still in its infancy, but scientists are optimistic and with good reason. Despite the challenges, the promise of nuclear fusion makes it an enticing prospect for our energy future. With every passing day, we inch closer to unlocking the sun's secret and bringing the power of the stars down to Earth. So, what does the future hold for nuclear fusion? In the quest to harness the sun's power, we're witnessing significant strides in nuclear fusion research and development. Around the globe, ambitious projects like the International Thermonuclear Experimental Reactor, or ITER, and the National Ignition Facility, NIF, are pushing the boundaries of our knowledge and technology. ITER, a colossal international collaboration, is working to demonstrate the feasibility of fusion power on a commercial scale. With its state-of-the-art tokamak reactor, ITER aims to generate 10 times more energy than it consumes, a feat yet to be achieved in fusion research. Meanwhile, on American soil, the NIF is taking a different approach, using high-powered lasers to create conditions necessary for fusion. Their goal? To ignite a self-sustaining fusion reaction, something akin to lighting a star here on Earth. But these mammoth projects aren't the only players in the fusion game. Emerging technologies like artificial intelligence and machine learning are joining the fray, offering new ways to overcome the complexities of fusion. From optimizing plasma conditions to predicting system disruptions, AI is helping to expedite the path to practical fusion power. Despite the challenges, the promise of fusion, an abundant, clean, and safe source of energy, is too great to ignore. The road to fusion power may be long and winding, but with each scientific breakthrough, we're inching closer to a brighter, fusion-powered future. While we have yet to crack the code of nuclear fusion, the future is bright for this potentially revolutionary energy source. So, nuclear fusion, a simple process in the sun, presents a complex challenge for us on Earth. But despite the hurdles, its promise as a clean, virtually limitless power source makes it a pursuit worth our best efforts. As we look forward, the future of fusion is bright, full of potential and brimming with promise. As we continue to unravel the secrets of nuclear fusion, we edge closer to a potentially game-changing energy source. If you found this topic fascinating, don't forget to like this video and subscribe to our channel.